In the 1920s, long before smart speakers, digital assistants, or automated lighting systems, an architect named E.D. Deforest imagined something radical. He designed a house that could manage itself. Blueprints from the period show rooms laid out with integrated mechanical systems, hidden controls, built-in features meant to reduce manual labor. It wasn't just a stylish residence, it was a prototype for what Deforest called a future home. A dwelling designed around efficiency, automation, and convenience, at a time when most houses still relied on manual effort for basic tasks. The idea feels modern, almost familiar. But in the context of the 1920s, it was unusual. Inside the design, Deforest proposed systems that anticipated later concepts of home automation. Centralized controls could regulate lighting. Mechanical mechanisms could simplify household chores. Appliances would integrate into the structure rather than sit as separate objects plugged into walls. Instead of treating technology as an add-on, he treated it as architecture. At first glance, the timing seems perfect. The 1920s were an era of industrial growth and consumer excitement. Electricity was spreading into urban homes. Refrigerators, radios, and vacuum cleaners were beginning to appear as symbols of modern living. Americans were embracing machines that promised to reduce domestic labor. So why did Deforest's future home fail to gain traction? Part of the answer lies in cost and scale. Building such a house required specialized design, custom engineering, and materials that pushed beyond standard construction methods. Most homeowners in the 1920s were not prepared to invest in experimental architecture. Housing demand existed, but affordability mattered more than innovation. Banks and developers favored predictable designs that could be replicated quickly. Standard floor plans reduced risk. Mass production in housing followed similar principles to mass production in automobiles. Custom mechanical integration increased complexity and expense, making Deforest's concept difficult to commercialize. Another factor was technological maturity. Although electricity was expanding, home electrical infrastructure was still inconsistent. Rural electrification had not yet reached large portions of the country. Even in cities, power systems were not as stable or standardized as they would later become. Automated controls require reliable energy supply. Without consistent electricity, advanced mechanical integration loses practicality. Some elements of Deforest's vision depended on mechanical systems that were innovative, but not yet refined, for long-term durability. Early automation often relied on gears, pulleys, and mechanical triggers. These systems worked in controlled demonstrations, but maintaining them in everyday household conditions posed challenges. Repair expertise for such specialized features was limited. There's also the question of social readiness. In the 1920s, domestic life followed established patterns. Household labor was structured around human management rather than machine coordination. Introducing automation into private homes meant redefining how families interacted with space and routine. That shift required cultural acceptance, not just technical capability. While urban elites occasionally experimented with futuristic designs, mainstream consumers approached housing cautiously. A home wasn't a test laboratory, it was a long-term investment. Reliability mattered more than novelty. Interestingly, Deforest's concept did align with broader architectural movements of the time. The period saw experimentation with modernism, functional design, and streamlined aesthetics. Architects explored how technology could reshape living environments. But many of those ideas remained theoretical or limited to showcase properties rather than widespread adoption. The future home may have been displayed or discussed in professional circles. However, documentation suggests it never evolved into large-scale development. Without strong financial backing or industrial partnership, the project lacked the manufacturing support necessary to turn blueprints into a housing trend. It's important to note that failure here doesn't mean irrelevance. Many design elements proposed in the 1920s would later appear in different forms. Central heating became standard. Built-in appliances became common. Electrical control systems evolved into programmable thermostats and eventually digital smart home platforms. What Deforest imagined in mechanical form would re-emerge decades later through electronics and software. But timing determines impact. Had the future home appeared in the 1950s, it might have found a broader audience. Or had automation technology matured earlier, adoption could have accelerated. Instead, it remained ahead of its environment. The story of E.D. Deforest's future home raises a deeper question about innovation. Is an idea powerful enough on its own, or does it depend on external systems aligning with it? In this case, the design was ambitious and conceptually strong. It demonstrated foresight about efficiency in integrated systems. Yet economic constraints, limited infrastructure, and conservative building practices kept it from scaling. Today, when we see smart homes controlled by apps or voice commands, we are witnessing the digital realization of principles that architects like Deforest sketched nearly a century ago. The technology changed. The intention did not. That gap between vision and execution explains why a prototype home that once seemed revolutionary quietly slipped into history. As the 1920s progressed, the broader housing market moved in a different direction than Deforest's experimental vision. Mass production reshaped construction just as it had transformed automobiles. Developers favored repeatable layouts, standardized materials, and efficient building techniques that reduced cost per unit. The future home concept, by contrast, required customization. Its automation systems weren't plug-and-play modules that could simply attach to any structure. They were integrated into the design itself. That integration increased complexity during construction and created dependency on specialized components. In an era when builders were focused on speed and affordability, complexity worked against adoption. Another quiet obstacle was maintenance. Mechanical automation in the 1920s depended heavily on physical linkages, cams, switches, motors, and interconnected parts. These systems required periodic adjustment. Dust, humidity, and everyday wear could affect performance. In a private home, consistent technical servicing was not always practical. Homeowners typically relied on local repairmen, not specialized engineers familiar with custom automation architecture. Without accessible maintenance support, even a well-designed system can become unreliable over time. At the same time, consumer technology itself was still evolving. Electrical appliances were entering the market, but they were separate devices rather than embedded systems. Refrigerators stood alone. Washing machines operated independently. Radios sat on tables as objects of entertainment. The industry model favored modular products that could be purchased individually instead of infrastructure embedded directly into a house. That market structure made Deforest's approach difficult to commercialize. There's also a financial reality tied to the broader economy. The late 1920s ended with the collapse of the stock market and the onset of the Great Depression. Housing investment slowed dramatically. Risk tolerance shrank. Experimental construction projects became even harder to justify when economic stability was uncertain. In times of financial pressure, innovation often retreats to proven models rather than ambitious prototypes. It's possible that the economic downturn played a decisive role in preventing the future home from scaling beyond concept or limited demonstration. Even if interest existed among architects or forward-thinking clients, securing capital during a financial crisis would have been extremely challenging. Yet despite its limited impact, the idea itself continued to echo in architectural thinking. Mid-century designers revisited automation in different forms. Centralized climate control systems became standard in commercial buildings. Automated lighting and environmental sensors emerged later as electronics matured. The dream of a house that responded intelligently to human presence didn't disappear. It evolved with new technology. The key difference was the enabling infrastructure. In Deforest's time, automation required mechanical engineering embedded into the structure. In later decades, automation became software-driven and electrically integrated, reducing the need for complex physical linkages. Microprocessors replaced gears. Sensors replaced mechanical triggers. Digital control simplified what mechanical systems once struggled to manage at scale. If we look at the future home through modern eyes, it appears almost prophetic. It recognized that domestic labor could be reduced through system design. It understood that technology should integrate with architecture rather than sit beside it. It anticipated a future where control over the home environment would improve comfort and efficiency. But foresight alone does not guarantee market transformation. For an innovation to reshape society, it needs affordability, infrastructure support, manufacturing capacity, and consumer demand aligned at the same moment. Deforest's concept had vision, but lacked that alignment. That gap explains why it remained largely unnoticed outside specialized circles. There were no mass production runs, no widespread developer adoption, no industry standard built around its principles. Instead, it became a historical footnote, a prototype that hinted at possibilities but never crossed into mainstream construction. Today, when smart thermostats adjust temperature automatically or voice assistants turn off lights with a command, they fulfill pieces of what the future home imagined nearly a century ago. The difference is that modern systems ride on digital networks and scalable manufacturing ecosystems that simply didn't exist in the 1920s. So the deeper question isn't why Deforest's idea failed in isolation. It's why the environment of its time couldn't absorb it. And to understand that fully, we have to look at how technological ecosystems mature, and what conditions finally make home automation move from experimental blueprint to everyday reality. After the economic shock of the Great Depression and the disruptions of World War II, the housing industry rebuilt itself on principles that favored standardization over experimentation. Suburban expansion in the 1950s prioritized mass production. Builders constructed thousands of nearly identical homes using streamlined methods that reduced cost and accelerated delivery. Ironically, that period created the foundation that automation would later depend on, but not in the mechanical form Deforest had imagined. Instead of embedding complex physical control systems into the structure itself, post-war builders treated appliances as independent units. Central heating systems became standardized. Electrical wiring became more uniform. Kitchens were designed to accommodate refrigerators, stoves, and later dishwashers as plug-in technologies. Automation emerged gradually through modular upgrades rather than integrated mechanical architecture. This shift mattered. The market proved that flexibility outperformed heavy customization. Homeowners preferred the ability to upgrade individual devices without rebuilding entire walls or rewiring entire systems. Manufacturers benefited from mass production of standardized components. Retail distribution scaled more easily when products were portable and replaceable. In that framework, Deforest's future home would have required a different economic model. Such coordination between builders and equipment manufacturers was rare in the 1920s and remained uncommon for decades. Technological progress eventually caught up with the underlying ambition of the concept. By the late 20th century, microcontrollers, sensors, and wireless communication made centralized digital control possible. Programmable thermostats replaced manual adjustment. Motion detectors automated lighting. Later, internet-connected devices enabled remote monitoring and voice control. These systems achieved something similar to what the future home aimed for, responsiveness and efficiency, but with far less physical complexity. The key difference was scalability. Digital automation could be added to existing homes without structural redesign. Consumers could install devices incrementally. That lowered barriers to entry and expanded adoption. Mechanical automation embedded into architecture, as envisioned in the 1920s, required upfront commitment and higher construction costs. Looking back, it becomes clear that Deforest's proposal was not technically impossible. It was economically premature. The components needed for his vision existed in early forms, but they lacked the cost efficiency and reliability that mass adoption demands. Electrical supply systems were still expanding. Industrial manufacturing had not yet optimized for precision mass production of small automation components. The supporting ecosystem simply wasn't mature enough. That context explains why the project attracted attention, but not transformation. Architectural journals and technical publications may have discussed the concept as an example of forward-thinking design, but mainstream builders were focused on practical housing shortages and affordability. Investors prioritized ventures with predictable returns. Experimental automation did not align with those priorities. As decades passed, the memory of the future home faded, preserved mostly in design archives and historical references. It resurfaced occasionally in discussions about early smart home concepts, often cited as evidence that automation in domestic spaces has deep roots. Yet its obscurity also highlights an important pattern in innovation history. Many breakthrough ideas appear long before the world is ready to implement them at scale. They demonstrate feasibility, but lack infrastructure alignment. Later generations rediscover similar principles under different technological conditions and succeed because the environment has evolved. In that sense, Deforest's project wasn't forgotten because it failed completely. It was overlooked because it preceded the systems that would eventually make it practical. Today, when automated lighting adjusts to natural daylight or a home system optimizes energy consumption automatically, we see the realization of a dream that architects like Deforest sketched nearly a century ago. The tools changed from mechanical linkages to digital networks. The objective, efficiency through integration, remained consistent. The prototype home did not reshape the housing industry in the 1920s, but it planted an early blueprint for thinking about architecture as a platform for technology, and that quiet influence raises one final reflection. Innovation sometimes succeeds not by immediate adoption, but by planting concepts that future technology can finally support. The future home stood ahead of its era, waiting for an infrastructure that would arrive long after its original moment had passed. In the decades after Deforest's concept faded, the core idea behind the future home quietly reappeared under new names and new technologies. It didn't return as a mechanical blueprint tied to walls and gears. It returned as software, sensors, and network devices layered onto existing structures. The difference in execution reveals why timing matters so much in technological adoption. By the late 20th century, home automation systems began appearing in high-end custom houses. These early systems were expensive and complex, often installed by specialized technicians. They controlled lighting scenes, security systems, and climate settings through centralized panels. In many ways, they echoed Deforest's ambition, centralized control over household functions. But even then, adoption remained limited to affluent consumers. The real turning point came when microprocessors became cheaper and wireless connectivity became widespread. Instead of rewiring a home, homeowners could install smart bulbs, smart thermostats, and connected security cameras individually. Automation became modular rather than structural. That shift solved one of the key barriers that doomed earlier integrated concepts: cost and flexibility. If Deforest's future home required building automation into the physical foundation, modern systems allow automation to be layered on top. Builders no longer need to coordinate every technological upgrade at construction. Consumers can upgrade gradually as products improve. This incremental model aligns better with market behavior. It also highlights why the future home struggled to scale. Its design assumed a level of coordination between architecture and technology that the industry ecosystem of the 1920s simply did not support. Appliance manufacturers operated separately from home builders. Electrical infrastructure varied by region. There was no standardized automation platform to unify components from different suppliers. Without that coordination, integration remained expensive and rare. Economic volatility further reduced the likelihood that investors would fund large-scale implementation. After the stock market crash of 1929, capital became scarce. Housing development slowed. Risk-taking in experimental design decreased sharply. Even promising innovations often stalled under financial pressure. So the project did not disappear because people rejected automation. It faded because conditions did not allow it to mature. Looking at historical records, there is no evidence that Deforest's concept led to mass construction or an operational housing community built around full automation. Instead, it exists today as a prototype idea, documented through plans, descriptions, and references that show what could have been. That status actually makes it important. It demonstrates that the desire to automate domestic life predates digital technology by nearly a century. It shows that innovation often begins with imagination before the tools exist to support it. When we evaluate technological progress through that lens, the future home becomes less of a failed experiment and more of an early signal. It identified a problem, domestic labor inefficiency, and proposed a systems-based solution. The implementation lagged behind the idea, but the concept resurfaced later when technology finally aligned with affordability and scalability. Today's smart homes operate differently in structure, but similar in purpose. They aim to reduce manual effort, optimize energy consumption, and centralize control. They rely on cloud computing, artificial intelligence, and networked communication rather than mechanical systems. In a way, Modern automation confirms that Deforest was not wrong about direction. He was simply early. And history often treats early visionaries as obscure figures because their environment could not yet convert vision into widespread practice. The prototype home he imagined remains a powerful example of how architecture and technology intersect, and how success depends not just on creativity, but on timing, infrastructure, and economic alignment. Sometimes the future does not fail. It just waits for the world to catch up.